LCDs, addition and subtraction. So that's what we're looking at in this assignment here. Excuse me. All right, so let's take a look. We're going to talk about first thing, which is finding LCMs by factoring. All right, so we're going to take a look at that first. So let's recall something really quickly. Let's recall, adding fractions, just adding fractions. All right, example 5/42 plus 7/12. All right, what if we were adding these fractions here? As you can see, what we have here are two unlike fractions, right? And what we have to do is find, normally what we do is we just find the LCD, right? So we find the LCD to add, all right, these unlike fractions. Right, and the way that we usually show in a, when this stuff is taught, let it be, third or fourth grade, it's just you kind of like make a little multiplication table, 12/42, right? You do times 1, you do times 2, you do times 3. Let me fix this line here. Until you find its pair. Right, what do we have? 12. We have what? 24. Over here we have 36. All right. Over here we have 42. And then notice that we have 84. And it really gets bigger. So I'm going to continue on the top and do times 4. Right. And when we do that, I think that's where we see our next one, right? All right, 48, but we're still not quite there, so we have to go a little further out, right? Times 5, times 6, right? What do we get? We got 60, right? We got 72 times 7, right? Times 8. Let's see how far we have to go here. Looks like we find our LCD, right, to be 84. All right, so I think about the smallest number here. This is the way of finding the LCD, right? But let's see if we can approach it a different way. Take a note of the title of the section, right? It's said by factoring instead, right? So instead, let's take a look at finding it by factoring. Right, and we really call, when we're just dealing with numbers, we call it prime factoring. All All right, you look at your 12 and you break that up. Right, well, what times what gives us 12? One possibility is what? 4 times 3. But then you even break that 4 up, so it's 2 times 2 times 3. And as we look at 42, right, what times what gives us 42? Well, that looks like a 6 and a 7, or in other words, the 6 is a 2, a 3, and a 7. All right, so now that we prime factorize them, we look at the different factors, right? We look at these factors. Notice that we have 2s, 3s, and 7s. All right. We have 2s, we have 3s. Well, let me not show it like that yet. We have 2s, we have 3, and 7 as our factors. All right, 2, 3, 7 are factors. But what we do is we pick the factor that is seen the greatest. Right, we choose the factor that is seen the greatest on each one of these. Right, we look at them and we say which factor is seen the greatest. Well, and keep in mind, before I continue, let me just give you all another minute. Does anyone need another minute to copy this down? Okay. I just want to rewrite that part here, right? Our 12, I said was a 2, 2, 3. Our 42, I said was a 2, 3, 7. We saw 2, 3, 7 are the factors. So the LCD may be found by including all different factors. That's the first thing, right? By including all different factors. And we want to use each factor the greatest number of times that it occurs in any one prime factorization. Right, and that's really important here. This star on how we find it. We're looking at two things when it comes to this. First of all, it has to have all the different factors and the greatest number of times that we see it in any one prime factorization. So if we look at this again, LTD has to have a 2, has to have a 3, has to have a 7. Notice on the top one, two is seen twice. 3 is seen once. Over here, 2 is seen once. 3 is seen once. 7 is seen once. So the fact that we see 2 and twice, we see 2 seen twice, 2 seen once. The biggest one is the one on the top. 3 is seen once, 3 is seen once. They're both the same, so we just pick one of them. 7 is seen once, so that's it. Right, so the LCD would be 2 to the power of 2 times 3 to the power of 1 times 7 to the power of 1, which ends up giving us 84. And this is what we're going to be doing. Finding LCDs, the only difference is that we're going to be doing it for polynomials. Or we factor. Right, so we prime factorize, break it down, and then include every factor. And then we pick the greatest number of times that it occurs in any one prime factorization. Any questions, y'all, so far? All right, let's take a look at an example. Find this LCD. Also, we can refer to it as LCM. Same meaning, least common denominator or least common multiple. All right, that's what they mean. Of 18 and 24. So we want to break up these numbers, prime factorize them as much as possible, break it down to their prime numbers. $18 breaks up to, I mean, a couple of different ways to do it, but if you decide to do just like 9 times 2, that 9 is then 3 times 3, and you have your 2. All right, the 24, many ways of doing it, but let's just state it 6 times 4, right? Then that breaks up to 3 and 2 for the 6. The 4 is 2 and 2. So your LCM has to have a 3, has to have a 2. Three, we'd give it to the power of 2 because we see it twice up there. 2 would be a power of 3 because we see it 3 times down here. And we just multiply that out. Looks like we get 72. Any questions, y'all? Any questions? All right. Let's take a look at another example. 12xy to the power of 2 and 15x to the power of 3y. So if we look at these 12xy to the power of 2, right, and we have 15x to the power of 3y, we just break them up. All right, your 12 is something like 2 times 6. I don't know, in other words, 2 times, your 6 is 2 times 3. You have 1x, you have 2 y's. 15 is just 3 and 5. But you have 3 x's and you have a y. That should be enough to find your LCM. What are the different factors? Well, we see a 2, we see a 3, we see a 5, we see an X, and we see a Y. It has to have all the different ones. Now we just take a look at how many times we see them. 2 is seen twice. It's got to be 2 to the power of 2. 3 is seen once on the top and once on the bottom, so it's just 1. 5 is only seen once, so it's just 1. X, the more times that we see it, is in the bottom. 3 times, so x to the power of 3. Y, the greatest amount of times we see it is on the top, twice. It's y to the power of 2. Any questions so far, y'all? Multiplying this out gives us 60x to the power of 3, y to the power of 2 as the LCM. Questions, y'all, with this example. Any questions? Okay, but let's really look at these problems in regards to what we've been doing. We've been factoring, right? So these are some nice, simple problems to start off with. But let's take a look at finding some LCMs of polynomials. So we got 3 polynomials, a trinomial, a binomial, and a binomial. We want to find the LCM here. This is what your homework will kind of start looking like. Right, we want to find the LCM here. Right, so with numbers, we prime factorized. With polynomials, we just factor. Factor that. Factor that. Factor that. There should be some really nice examples to factor. The top factors out looks like x plus 1 times x plus 1. All right, the product of 1, that gives you negative, gives you 2. Next one, that's that one. That one looks like it's a GCF. Pull out a 5, left with x squared minus 1. Or, I'm sorry, I missed this x, right? It was up there. So let's go back. If it's 5x, or we pull out a 5x, and it looks like that leaves us with x minus 1. This one looks like it's difference of squares. X minus 1, x plus 1. Should be enough to allow us to find our LCM. We have x plus 1 that we see twice up there. X minus 1, all of this right here. 5x and x minus 1 is just all seen once there. So it looks like our LCM here is 5x times x plus 1 times x plus 1 times x minus 1. Any questions there? Let's call this example A. How about example B? x squared minus y squared x to the third plus y to the third, and x squared plus 2xy plus y squared. All right, so let's factor them. All right, x squared minus y squared looks like it's just x minus y and x plus y. X to the third plus y to the third. That looks like it's x plus y. Times what is that? X squared minus xy plus y squared. Is that right? Yes. And then x squared plus 2xy plus y squared. What is that? X plus y times x plus y? Yes, it is. Should give you enough there to find the LCM. Notice that x plus y seen twice down here. We just have 1x minus y, and we just have this x squared minus xy plus y squared. And I don't think that factors. Product of 1 that gives us negative 1. So LCM will be all of that there. An x minus y, an x plus y, an x plus y, and an x squared minus xy plus y to the power of 2. Any questions there? Any questions? So why are we finding these LCMs? Because in order to add or subtract fractions, we're going to see how important it's going to be. So let's take a look at, first of all, just adding and subtracting these rational expressions with like denominators. Adding, subtracting rational expressions. Remember, with like denominators, it's nice and easy. 1 over 4 plus 2 over 4 is just 1 plus 2 over 4, or in other words, 3 over 4. Right? So if they are like denominators, just work with the top, keep the denominator the same. Three plus x over x plus 4 over x. Right, so they're both the same, so we just do 3 plus x plus 4, everything goes at the top, and it's over x. We can simplify the top. 3 plus 4, we get 7 plus x over x, and that's all we can do here. Any questions here, y'all, with this nice example? All right, let's take a look at our next example. Anyone need another minute copying this down? All right. We got 4x to the power of 2 minus 5xy over x squared minus y squared. And we are adding that to 2xy minus y to the power of 2 over x squared minus y squared. A really nice example here because these denominators are the same. So all we have to do is just one fraction. All right, put all the numerators here in one fraction. It's over x squared minus y squared. Any questions here? Looks like the middle can be combined. That top one's a little bit more work. Let's see if we can factor that out. And I think we can because that's product of, right, 4 times negative 1, which is negative 4. Is there product of negative 4 that gives us negative 3? I think there is, right? Negative 4 and 1. Right, so we factor out, remember, we show this is 4x squared minus 4xy minus 1xy minus y squared. And then after you do that, you do your factor by grouping. But just to save some time, I'll just show, all right, in factored form. All right, what do? We pull out a 4x, leaving us with x minus y. Here, pull out a negative 1, leaving us with x minus y. So our factored form, all right, looks like this. So that's what the top is. All right, the top is that. The bottom is just x minus y, x plus y. And if you notice, we have some cancellation there, leaving us with just 4x minus 1 over x plus y. Right, so a nice example of adding these like fractions and then having to simplify. And this is what we were doing last class. Right, last class we were simplifying, so we see simplifying coming back into play. Any questions with this example, y'all? Any questions? All right, let's take a look at our next example here.
Hold on, can you go back?
Yes, sir. Just let me know when you're done there, please.
All right.
Did you say you were done, William?
No, not yet. Hold on.
Oh, okay.
All right, I'm done.
Oh, all right. Let's take a look at another example here. We have 4x plus 5 over x plus 3 minus x minus 2 over an x plus 3. So this one, also a nice one because of the fact that the fractions are like, right? We have like denominators. So we would do 4x plus 5 minus. We do want to be careful because we're subtracting that entire other part there. So one thing that I do want you to note, we talked about this before, is that it's important that you put parentheses. Must use parentheses right after a minus sign. And this is something that you will see quite a bit on the test, y'all. I think it's really students being able to notice that that really makes that difference, just between a B and an A student. We want that A student to catch that, so make sure you notice that if you see a minus sign, after that minus sign, there should be parentheses. Because that leaves us with 4x plus 5 minus x plus 2 after that minus sign is distributed. So just be careful with that part there, okay? Now from there, it shouldn't be too bad. Now we can just combine our like terms, right? 4x minus x, right, gives us our 3x. And then when we add 5 and 2 gives us a 7, and that's over x plus 3. And not a whole lot we can do there. That looks like that answer right there is in lowest terms. But really, the whole purpose of this example is to show that that minus sign plays a big role there, okay? Any questions with this example? Does anyone need another minute copying this down? All right, moving on here. So, and these first examples were really nice because all of these examples we were adding or subtracting fractions with like denominators. But now I want us to go ahead and take a look at adding or subtracting with unlike denominators. Oh, let me go back. So if we have unlike denominators, let's recall what we do, right? Let's take a look at an example. 1 over 2 plus 2 over 3. Right? What is it that we're really doing here? We're multiplying the first one by what?
3.
First one we multiply by 3. And the second one we multiply by what?
2.
2. All right. Leaving us with 3 over 6, right? Plus a what? 4 over 6. And this is how we get our answer, right? Right, 3 plus 4 over 6. In other words, 7 over 6. Right? So this is the same kind of idea that we're going to be working with. The only difference here is that we're not working with numbers. We're going to be working with polynomials. Right? So let's take a look at our first example. I want you to add 2a over 5 plus 3b over 2a. All right, so let me go ahead and just rewrite the problem. So we take a look at what we just did up there. What are we going to be multiplying the first fraction by? What do you think?
2a.
Good. 2a. And what about the second fraction?
5.
Good job. All right, very good. All right, so doing that, we're going to get two new fractions, right? Both the denominators should just be 10a, right, everybody? All right, the denominator should be 10a. Multiply the top. 2 times 2 is 4. What's 8 times a? Should be 4a.
It said 8 times 8.
A, the letter A times the letter A.
Oh, squared. 2a
Good.
squared.
Or 4a squared, because 2 times 2, right?
What?
We multiply 2 times 2, gives us 4. Then we multiply the letter A times the letter A, giving us 4a squared on the top.
Yeah, I already wrote the 4.
Does that make sense there?
Mm-hmm.
All right, and what about the second one? What do we get the second numerator to be?
15b.
Very good, 15b, right? So now from there, we can go ahead. Now the top is 4a squared plus 15b over 10a. Can we reduce this any further? Right, because remember, before we decide to claim a solution, we want to see if it can be reduced any further. And it doesn't look like it can. Right, because the top, no GCF. Right, there is no GCF, which means we can't really do anything. So this is our answer there. So a nice first example of adding some fractions with unlike denominators. Any questions, y'all, with this example? Let's take a look at the next example. I would suggest giving yourself some space. I think we're going to do a little bit of work on this one. Right?
Can you go back really quick? I'm sorry.
Yes, of course, of course. And just let me know when you're done there.
Okay, I'm done.
All right. So give yourself some space for this one here, y'all. We're gonna do a little bit of work to this one. We have 3x squared plus 3xy over x to the power of 2 minus y to the power of 2. And we're going to be adding that to 2 minus 3x and x minus y. So before we approach this problem, I want us to think about what we did in the previous example, right? These are unlike, so if we follow what we did in the previous example, what would we be multiplying the first fraction by? Top and bottom.
X minus y.
X minus y. I don't want you to write that down. I just want you to think about it, okay? But I will write it down, but do not write it down, okay? What about the second one? What would we be multiplying that by?
X squared minus y squared.
Yeah. And if you notice it, it's making it look really ugly, isn't it?
Uh-huh.
All right. So let's try to approach it differently. Before we just jump into that, let's just see, right? The question that I want to ask you here is, can we factor the denominators?
Yes.
Yeah, we sure can. We can factor one of them, can't we?
Mm-hmm.
We can factor the first one, right? So we rewrite our numerator. What does the first denominator come out to be in a factored form?
X minus y, x plus y.
Great job. Right, and let's bring everything else down now. Right, so all we did was factored out the first one. Factored this first one, we saw that this one, the first one was definitely possible, right? We saw that we can definitely do that. So now maybe it makes it a little nicer, right? So do we really have to multiply both denominators? Think about it, y'all. Yeah,
other one by x plus y.
Great job. This is already x minus y, x plus y. This has the x minus y. It's just missing something else. So now instead of doing all of that multiplying both sides, all we're going to do is just multiply this one by x plus y. X plus y. Now our denominators are going to be alike. That makes it a lot nicer, doesn't it? Right? So what are we left with? We're left with 3x squared plus 3xy plus, now we just do our, I'm going to use a different color there. Now we just multiply. Right? This is why we learned this stuff in 4.2, right? Because it's coming back again. Right? We multiply, FOIL, distribute, whatever you want to call it there. That should leave us with what there? Let's start with the 2.
2x
Good. Plus?
plus 2y.
Good. And then after we distribute the negative 3x?
Negative 3x squared.
Good.
Negative 3xy.
Good. I'm only going to show one fraction now because my denominators are the same.
Mm-hmm.
Make sense, everybody?
Mm-hmm.
Now from there should be pretty easy. Just simplify the top. Right? Notice I got 3x squared, that's positive. I got negative 3x squared, that's negative. I'm canceling that out. I got a positive 3xy. I got a negative 3xy.
Cancel that out. And then you got 2x plus 2y.
Okay. 2x plus 2y over x minus y times x plus y. Are we done? Can we simplify?
Yes.
Yeah, because on the top, what can we do?
Factor it out.
Good job. The top has a GCF of 2. I mean, if we factor it out, what is the top left like?
2x plus y.
Good. 2 open parentheses, x plus y close parentheses. Rewriting the bottom. And notice what happens now.
Now you can cancel out the x plus y.
Great job. Canceling out the x plus y, leaving us with an answer of 2 over x minus y. This is a great problem. Right? This is a really nice problem. One that I think would be great to put on the exam. Any questions with this example, y'all? Really quickly, I'd like to mention, it was great to see, a student in this class. I saw the students, I think, yesterday, and then definitely quite a bit today as well. The student was in, some of my classes yesterday, was in, found me in the office, was also in the math lab practicing, and it was nice to see a lot of great work out of the students, so. If you guys see this work to be involved, I would strongly encourage you to follow along with what this other student is doing. Come see me, sit in my other classes, practice, because this is what your test looks like, everybody. Your test, this is a perfect example of what you'll see a lot on your exam. So a nice example. Questions, comments, concerns before we do the next one? All right, moving on. 2y plus 1 over y to the power of 2 minus 7y plus 6. We're going to subtract that to y plus 3 over y to the power of 2 minus 5y minus 6. All right, so notice here a rational expression minus a rational expression. Notice that they both have different denominators. What do you think would be a good idea to do first here?
Factor out the denominators.
Great job, right? Let's go ahead and factor, right? And notice that you should be able to factor both of them, right? 2y plus 1. That should be a nice one to factor out. Y plus 3, even that one should be very nice to factor out. All right, they're both trinomials. Leading coefficient is 1. So to get the first one to be, looks like the first one in factored form is a what is it, a -6 and a -1? -6, -1, +6, you add those, -7. And what about the next one there in factored form? What would that be?
3 and 2. Or
Good, a -2, a -3. Great job. Very good, very good. Okay, so now the question is, what are we going to multiply? What are we going to be multiplying here by? Or, let's see. Oh, it's not -2 and -3. Because that gives you a +6. So it's going to be something different instead. What is it going to be?
It's 6 and 1.
Good, a -6.
Yeah.
A -6. Oh, what just happened here? A -6 and a +1. Yeah, because we need to get it to be a -6. Okay. The reason I knew it didn't work because it looked like we're gonna have to do way too much, and we're not gonna make it that complex where you have to multiply by everything. So what do we have to multiply the first one by?
Y plus 1.
Good. And then the second one by?
1 minus 1.
Good. Now notice that both the denominators are the same, right? So if we were just to write a long fraction, the bottom would be, it doesn't matter the order of it. Sometimes students ask, is there an order? No, it doesn't. All right. And I just start working at the top. I'll give you a minute to work that out. All right. Hopefully it doesn't take too long. Should be some nice review, but I'll give you a minute to work that out. Also work this one out. But something that's very important to note, I talked about this a little earlier. We see it coming back. Parentheses. Because of that minus sign. So it's going to be minus whatever you get the second part to be. So very important to note that. So I'll give you a minute to do that there. All right, looks like we should be left with what? 2y squared. Looks like it's a plus y. Then looks like it's a plus 2y. Then looks like it's a plus 1. That was done correctly on my end. All right, 2y squared plus y plus 2y plus 1. On the other end, it's a y squared minus 1y plus a 3y minus 3. Hopefully it looks okay. Anyone get anything different? Okay, and I am going to, right, we can start doing a couple of things here. It just depends on how you want to approach this. You know, this negative is going to change all these signs, that's for sure, right? Right, so you're left with 2y squared. You can already combine those. That's plus 3y plus 1 minus y squared plus 1y minus 3y plus 3. All right, working the top over to the bottom. Now you can just simplify the top completely. All right, so we do that. We're left with what? Looks like y squared, right? 2y squared minus y squared is y squared. All right, then what do we have? We have 3y plus 1y, that's 4. 4 minus 3, right? 4 minus 3 gives us a positive y. Right, then we have 1 plus 3 gives us a positive 4 over y plus 1, y minus 6, y minus 1. Can we factor out the top? I don't think we can. Looks like that's our answer right there. It's a nice example there as well. Any questions there, y'all? Any questions? All right, so that's a nice, some nice examples of 5.2. Y'all, there's so many examples of 5.2. I mean, I take a look at the book and, you know, because that's what I use. That's where I get these examples from. And I mean, just on 5.2 itself, there's 92 problems. So there's so many examples. Make sure you're comfortable with that because you definitely see some of those problems on the exam. All right, y'all, let's move on here.